Have you ever gazed at the stars and wondered how they come into existence? It's a question that has captivated humanity for millennia, and today we have some pretty fascinating answers. Our journey begins in the farthest reaches of the cosmos, amidst vast swirling clouds of dust and gas known as nebulae. These nebulae are often referred to as stellar nurseries, and for good reason. For it's within these vast cosmic clouds that stars are born. The birth of a star begins with a whisper, a slight gravitational nudge. This force, as relentless as it is subtle, begins to pull together the dust and gas within the nebula. Over countless millennia, these particles start to clump together, growing denser and hotter with each passing moment. This is the beginning of a protostar. Now, a protostar is just a baby in cosmic terms, but it's a baby with a fiery heart. As the pressure and temperature at its core rise, something truly miraculous happens: nuclear fusion. This is the process where hydrogen atoms under extreme pressure and temperature start to combine to form helium. But this isn't just any old chemical reaction. No, this is a process that releases an enormous amount of energy. Energy so intense that it pushes outward, counteracting the inward pull of gravity. This delicate balance between gravity and energy release is what creates a stable star. And the result of this energy release, well, it's the very thing that makes stars so captivating to us: light. A star shines because the energy produced by nuclear fusion in its core makes its way to the surface and is released as light and heat. So that's how a star begins its life. A spectacular transformation from a mere cloud of dust and gas to a glowing sphere of plasma. A journey that takes millions, if not billions, of years. But for a star, it's just the beginning. So what happens after a star is born, and how does it spend the majority of its life? Well, after a star is born, it enters what's known as the main sequence stage. This is the longest period in a star's lifetime, where it continues to burn hydrogen in its core. You can think of this stage as a star's adulthood, a time of stability and energy output, just like the sun is doing right now. Now, stars, much like people, come in all sizes, and it's this size, or more accurately, the star's mass, that plays a pivotal role in determining its lifespan. You see, smaller stars, the ones with less mass, tend to burn their fuel more slowly, and as a result, live longer. They're the tortoises in the cosmic race, slow and steady, sometimes living for billions of years. On the other hand, larger stars, those with more mass, burn through their fuel at a much more rapid pace. They're the hares in our little analogy. These stars live fast and die young, at least in astronomical terms. They shine brightly, but their time in the main sequence is relatively short, often only a few million years. As these larger stars exhaust their hydrogen fuel, they begin to evolve, entering a new stage of life. Their cores contract, and their outer layers expand, transforming them into what we call red giants or supergiants. These stars become enormous, swallowing up nearby planets, and shine with a reddish hue. So you see, the life of a star isn't just about birth and death. It's about the journey in between. The burning of fuel, the balance of forces, the transformation from one state to another. It's about the evolution from a young star, burning bright and fast, to an older, wiser star, glowing red with the wisdom of ages. In essence, the life of a star is a delicate dance between gravity and pressure, a struggle that eventually leads to the star's ultimate demise. How does a star meet its end, and what remains after its death? Imagine a star, having spent millions to billions of years, burning brightly in the cosmos, finally exhausting its nuclear fuel. This is the beginning of the star's end. The outward pressure that once balanced the star's massive gravity decreases, and the star begins to collapse under its own weight. This is the start of the star's final act, its swan song, and it can play out in a few different ways. If the star is relatively small, like our own sun, it will shed its outer layers, leaving behind a dense core known as a white dwarf. This celestial object, about the size of Earth, but with a mass close to that of the sun, will glow hot for billions of years before gradually cooling and fading into the darkness of space. But what if the star is much larger, with a mass more than 8 times that of the sun? As it collapses, the crushing force of gravity compresses its core to an extent that's hard to fathom. The result is a neutron star, a celestial body with a radius of only about 10 kilometers, but with a mass up to twice that of the sun. Imagine a sugar cube weighing as much as a mountain. That's the kind of density we're talking about. And then, there are black holes, the remnants of the most massive stars. Their gravity is so intense that not even light can escape their grasp, making them invisible to our eyes. They are the ultimate end state of stellar evolution, the final curtain call in a star's dramatic life. But sometimes, the death of a star is not a quiet affair. It can end with a spectacular explosion known as a supernova. This cosmic fireworks display marks the death of larger stars, and it's so bright that it can outshine an entire galaxy. From birth to death, each star undergoes a captivating journey, leaving behind a legacy that continues to mystify us. And so the cycle of stellar life continues, with each death seeding the cosmos with the building blocks of new stars, new planets, and possibly new life. Now that we've traversed the life cycle of a star, what are the key takeaways from this cosmic journey? Let's embark on a quick recap. Each star begins its journey nestled within the cosmic dust and gas of nebulae. From there, it evolves into a main sequence star, burning brightly for billions of years. Depending on its mass, it may swell into a red giant or supergiant, the twilight of its life. The grand finale? A spectacular death, often resulting in a supernova, neutron star, or black hole. The star's mass is the maestro of this cosmic ballet, dictating the lifespan and ultimate fate of our stellar protagonist. It's a tale of transformation, of energy and light, played out across the canvas of our universe. This journey underscores the beauty and complexity of our cosmos. Each star, a unique narrative in the grand tapestry of the universe. The next time you look up at the night sky, remember, each twinkling light is a star at a different stage of its life, a testament to the spectacular life cycle of stars.